So let's look into dividing fractions. So this first one is 15 divided by 1/3. So if I had to use multiplication for this, it's division, but I know that if I use the reciprocal of the second number, it'll work and it'll give me the answer. So if I do 15, and I'm going to rewrite it as 15 over 1, and instead of divided by 1/3, I'll use its reciprocal, times 3 over 1. If I multiply 15 times 3, my numerators, it gives me 45. And if I multiply 1 times 1, I get 1. My answer here for this one is 45. That basically means this. I'm going to take 15 whole things. Here's one of those whole things. 15 whole things and cut them into thirds. Well, I get 3 parts here, but that's just after one piece. If I tried a second piece, I'd be up to 6. And if I tried a third piece, I'd be up to 9. And if I did this 15 times, I'd be up to 45. As I look at the next one, 3/8 divided by 3/4. That means that it is 3/8 times its reciprocal, 4 over 3. When I do this, what I'm trying to look for is if there's anything like diagonally or up and down that can be factored out ahead of time. I look here and I see that I've got like these two 3s here and a 4 and an 8. So these have like something in common. So what I'll do is I'll say that 3 and 3 can both factor out of 3. It would leave me with 1 and 1. And 4 and 8 can both be divided by 4. My answer ends up being 1/2. Now, if I were to show somebody what this looks like, what I'm basically doing is I'm trying to take 3/8 of a thing. So here's an entire whole. That's one thing. If I were to create eighths, what I'm starting out with is 3/8. I'm starting with this section. I'm trying to divide it into groups of 3/4. Well, if the fourths of a full thing look like this, and I'm supposed to cut it into a section that's 3/4, because this represents 3/4 of a whole thing, it looks to me like this 3/8 here is half of the whole thing I'm looking for, which makes sense because here's my 1/2. As I look at the next one, 2/5 divided by 1 and 2/5. First thing I need when I do these is I need fractions. So I have 2/5, that's working fine. And then I get divided by 1 and 2/5. I can't really deal with it that way. So I'm going to make it 7 over 5. So now it's 2/5 divided by 7/5, but 1 and 2/5 is the same as 7/5. It's just the improper fraction. Now what I'll do is turn it into a multiplication problem by multiplying by its reciprocal. I'll look for any shortcuts here of things that can factor. I think 5 and 5 can both be divided by 5, 1 and 1. My answer here is 2 times 1 is 2, and 1 times 7 is 7. My answer to this one, 2/7. Here's 3 more problems. You can try these 3, pause it here, or you can try them and pause them one at a time, and I'll go over the answers. Let's look at the first one, 24 divided by 1/6. 24 divided by 1/6 is the same as 24 over 1 divided by 1 over 6, or 24 over 1 multiplied by its reciprocal, which is 6 over 1. If I multiply 24 times 6, it'll give me 144 over 1, and my answer to this one is 144. If I look at the next one, 7/12 divided by 1/3, I'm going to make that 7/12 multiplied by its reciprocal, 3 over 1. I'll look for anything diagonally that can make it simpler for me. Divide both of these. 3 and 12 can both be divided by 3. It leaves me with 1 and 4. When I multiply it, I get 7 over 4. But I really can't leave it that way. That's not wrong, but it's not the best answer. I'd probably turn that back into a mixed number. 7 over 4 is the same as 1 and 3/4. As we look at this last one, 6/7 divided by 1 and 4/7. First thing I would do is make them into fractions, because that second number isn't a fraction. So I'm going to make 1 and 4/7 into 11/7. Then what I'll do is use the reciprocal and multiply. If I use the reciprocal, it looks like this. I'm trying to find any shortcut. So I see this 7 and this 7 can both be divided by 7. 1 over 1. 6 times 1 is 6. 1 times 11 is 11. My answer is 6/11.